Hey guys, welcome back to yet another video where we will be going through the gradient of a line. Now, in order to work with gradients and straight lines successfully, a good understanding of coordinates and linear graphs is needed. Well, what is a gradient? Well, let's find out by diving into the first very question. The gradient is a measure of slope. The greater the gradient, the steeper the slope. And the gradient is represented by the value of m in an equation, where you will have y equals mx plus c, and where m is seen as your gradient. Now, when the gradient of two lines are the same, they are known as parallel. However, when the gradients have a product of -1, they are perpendicular. So throughout this video, I will be going through everything in detail. So let's keep this as interactive as possible. Now, when you're calculating the gradient of a line, that is calculated by dividing the difference in the y coordinates by the difference in the x coordinates. And this may be referred to as the change in y divided by the change in x, or the vertical divided by the horizontal. And again, I will be going through all of this during our video here today. So thank you very much once again for joining. I hope this will be useful. So as we mentioned, the gradient is the amount of vertical movement for each unit of horizontal movement to the right. And as I mentioned, the greater the gradient, the steeper the slope. Now, in this particular question, we have a positive gradient, and that is because the slope goes up from left to right. So again, we're starting at the bottom here, and we're going all the way up to the right-hand side. So a gradient of 2 and a gradient of -2 would also mean that they have the same steepness. Now, a gradient of 2 slopes up from the left to the right, and the gradient of -2 slopes down from left to right. The parallel lines have the same gradient. Let's remember that. Parallel lines have the same gradient. And perpendicular lines are sloped in opposite directions, where one has a positive gradient and the other has a negative gradient. And so the product of their gradients is -1. So let's go ahead and dive into question number 1 here. They've given us line L, which is drawn on the grid below, and it's asking us to find the gradient of this line L. So as we said, it is now the movement between the vertical line and the horizontal. The first thing we need to do is find a specific point. And that could be a point here, anywhere where the line meets a corner, and a point here. Again, you can see there's another point below here, and then also a point on -4. But what we need to do is now make almost a right-angled triangle. And this is where we need to join our dots together. So as you can see, we've got a straight line down here and one across. You could do another straight line down here and one across, or again, a straight line down here and one across. And you can see now that these three triangles have something in common, where you drop down by 3 and you go across by 1. And again, many of you might see this as down the stairs and across the corridor, any way that you guys deem it fit. So let's take a look at what our gradient is and how we calculate it. Well, we can see that we're going down by 3 and 1 across for each and every one of them. So all we need to simply do is have 3 divided by 1, which gives us 3, and that is our gradient. And there we are. So once again, we've now divided our vertical by our horizontal line. That's 3 divided by 1, which gives us 3, and that is our gradient. And no matter what I use, what line I use, it's going to be very much the same. Let's take a different approach here. Let's say we are going all the way down to this section here and then joining it to this second dot. Let's see how many times we drop down by. So if we count all of our dots, we have 1, 2, 3, 4, 5, 6, and then we have 2 across. So if I now take this approach and have 6 divided by 2, we still get 3, which means our gradient is still the same as 3. And this is another way for you to check. But please remember, the gradient is a measure of the slope of a line. So it's the amount of vertical movement for each unit of horizontal movement to the right. So the greater the gradient, the steeper the slope. So the gradient of 3 that we have here is steeper than the gradient of 1 and gradient of 2. And again, if I want to write, and just to add on a bit more here, that this would be a positive gradient. Just to quickly reiterate once more, this would be your positive gradient for P, and this would be your negative gradient for N. And remember, that is your left to your right. And that is again because for the left, let's say we would have 2 down and 1 across. So you know 2 divided by 1 equals a gradient of 2. But for the right, we might have 1 across and 2 down. So then we have 1 divided by 2, which is again a minus, which will equal minus 2. Because again, we're going down, so it's going to be a minus 2. Marvelous. So P for positive and N for negative. Okay, I hope that was clear. Let's now move over to question number 2 here. So with question number 2, the line L has been drawn on the grid below, and let's find the gradient of line L. So again, we can go ahead and let's find our first point, and then our second point, and again we have 2 divided by 1, which we know is going to be 2. I can take a different point here just to show you that there's not just one way to get the answer. We can go straight down from here and then straight across because it joins another point. I'll have 4 this time and 2 here, and again the answer is still 2. Or if we take things even further, if we go down all the way across here and then make a point from here, we'll have 4 as our horizontal, and for our vertical we'll have 8. So then we'll have 8 divided by 4, which gives us 2. So our gradient is 2. Let's go for question 3. So question 3, it's exactly the same, but if you have noticed, the slope has become steeper. So as it becomes steeper, the gradient will become higher. So again, I'm going to zoom in just a little here. Let's find our first point and then our second point where it meets, and we can go all the way down and then across. So now for that reason, we have 4 down and 1 across. So 4 over 1 equals 4, and that is our gradient 4. So remember, the steeper the line gets, the higher the gradient. Okay, so question number 4. So for question number 4, what do we notice here? Well, we see that we have a negative slope from the left to the right, sloping down. So now we know our answer is going to be a negative. And if you remember, the gradient of the line is calculated by dividing the difference in the y coordinates by the difference in the x coordinates. And likewise, we can go ahead and draw out our triangle where we have 3 drops over 1. So we can have 3 divided by 1, which equals 3. And because it's a negative, we can now go ahead and put a minus 3 there. Marvelous work. Question number 5. So for question number 5, this is also a negative slope. So now we'll go ahead and find our points. Again, we can have our point at the very top here, and then also anyway down here where we have another point, and directly we can have 3 divided by 3, which is 1. But again, because it's a negative slope, it will be minus 1. But again, if we use our second method, and if we take the coordinates, which is minus 4 to 5, and then minus 1 to 2, we can now get the difference of our x and the difference of our y. So once again, remember, it's the change in y divided by the change in x. So if we have 5 take away 2, which is 3, and minus 4 take away minus 1, 2 negatives give you a positive, so that's minus 3. You know you'll get the answer of minus 1. and there we are. So please remember that we always take the coordinates of the points that are directly above the x-axis. So in this case, it's going to be coming down here and also to this point here. Marvelous. I hope that is clear. Let's now move over to question 6 and do yet another example. So now we need to find the gradient of line L once more. Again, we know this is a positive slope now as it's going from left to right. So let's go ahead and find our first point, one which is here, and our second point which is here. We'll then draw our line and complete our triangle, which means we now have a drop of 2 and we're going across by 4. So again, if we go ahead and write 2 over 4, that is equivalent to a half, and that is our answer. And again, if we take our second approach, where we use our coordinates, that can then give us 5, 3, and our second point can give us 1, 1. So again, as we said, it's calculated by dividing the difference in the y coordinates by the difference in the x coordinates. So again, the difference of our y coordinates is going to be 2, and the difference of our x coordinates is going to be 4. So 4 divided by 2 is 2, and that is our answer, which again is seen as a half. So 4 divided by 2 is seen as a half, and there we are. I hope that was clear. Let's now move over into the next question. So for question 7, it states, find the gradient of the line that passes through 2, 1 and 5, 10. So this time they haven't given us a graph to work with, but they've now given us the coordinates. And as we know, we have our gradient, which is the difference of our y over the difference of our x. Now please remember, this is exactly what I was doing in the previous questions. So as we know, I'm going to label 2 and 1 as your x1 and your y1, and your 5 and 10 as your x2 and your y2. Let's now go ahead and find the difference. So the first thing we're going to do is substitute. So the first thing we're going to do is substitute these values. So we'll have our gradient, which equals 10 minus 1 over 5 minus 2, which then gives us 9 over 3. And there we are. Our answer is 3. And that is exactly what we were doing in the previous questions, but then showcasing this on a graph. Let's now go ahead and do the very much same for number 8. We need to find the gradient that passes through 5, 4 and 7, 0. So again we have our gradient, which is our y2 over y1. Remember, that's the difference of our y over the difference of our x. So now we've gone ahead and done that. We know our x1 and y1 and x2 and y2. So we just need to now substitute this. So we'll have 0 take away 4 over 7 take away 5, which is then again minus 4 over 2, and that gives us minus 2. So we now know it's a negative slope as we have a negative answer. And that is your minus 2 there. Okay, question 9. Once again, if I just do this using arrows, this is what we are subtracting. So we'll have 8 minus 4 over 5 minus 3. You know, 8 minus 4 is 4, and 2 negatives give you a positive, so that is equivalent to 5 plus 3, which is 8, and that gives us a half. And there we are. Beautiful. I hope that was clear. Let's now move over to question 10. You guys are doing really well, and feel free to pause the video at any given time and attempt the question. Why don't you give this a go here for 10 and 11? You may begin. Okay, marvelous. Let's now go ahead and dive into question 10. So like we said, we had the difference of y over the difference of x. So again, we'll have 10 minus 7 is 3, and 1 minus 3 equals minus 2. If we divide that, that will give us minus 1.5, and there we are. And then for question 11, we'll do very much the same thing. We'll have minus 9 take away minus 1 over minus 3 minus 1. That then gives us minus 8, as the two negatives give us a plus, and we get a minus 4 below, which will then give us a positive 2, and that is our answer. So I hope you can see that we are using the same method throughout this entire time. Let's now dive into question 12. Again, we're going to do the exact same thing, where we'll have our gradient as minus 3 over minus 1 over 3 minus 8, where that gives us minus 4 over minus 5. If we negate the negative signs, we'll be left with 4 over 5, and that is our answer. So I hope you can see how we are utilizing this method for all of our questions. We're almost done here now, guys, so let's continue and dive into question 13. So for 13, once again, we have our gradient, which is going to be... Okay, so question 13. Let's now go ahead and find the gradient once again. Again, I'll go ahead and refresh our memory. So we have m, which equals the difference of y over the difference of x, where we have x here and y here. So again, we will have 9 minus negative 1 over minus 2 minus 3, which gives us 10 over minus 5, and that gives us minus 2. So now we know our answer here is minus 2. Once again, don't forget that two negatives give us a positive here. Okay, question 14. We'll do the same thing. We'll have 10 minus 2, and we'll have minus 3 minus 1, and that gives us 12 over minus 2. Don't forget it's negative 1, and that gives us minus 6. Marvelous. Okay, question 15. Very much the same thing now. We'll have 7 take away 4 over minus 5 minus 3, and that gives us 3 over minus 2, which is equivalent to minus 1.5. So I hope that was now clear, and this is all to find the gradient of a line that passes through specific points. But let's now take the final 3 questions as a bit of a challenge. So it says the line AB passes through the points A, 2 minus 1, and 6k. They've given us the gradient, which is 5. We now need to work out the value of k. So how do we go about doing that? Well, step 1, let's go ahead and write out x1, y1, x2, and y2. We will then go ahead and write out our formula, where we start off with m, but this time we know our m is 5. So we have 5 equals k minus 1 and 6 minus 2. Our objective is to find the value of k. So now let's go ahead and work this out. We have 5 equals k plus 1 over 4. We then can take the 4 to the other side, which then becomes a multiplied 4. So we have 20 equals k plus 1. And if we take this 1 over, it becomes a negative 1. And that's where we're left with 19 equals k. And that is our answer. So I hope that question was clear. We substituted all of our values in before making k the subject. And we'll do the exact same thing now for question 17. Once again, feel free to pause the video at any given time, attempt the question before pressing play. So again, step 1, we label our x and y spaces here. We'll then substitute the value in, which we know our gradient is 4. So we'll have 12 minus 4 over k minus 3. Once we've done that, we'll have 4 equals 8 over k plus 3. We can then take this entire thing over to the other side. So we'll have 4 and then k plus 3 in brackets. And remember here, we need to work out the value of k. So we are not going to expand these brackets, but instead I'll take the 4 over to the other side. So we have k plus 3 equals 8 over 4, which is our 2. If we have k plus 3 equals 2, we now need to make k the subject. So what am I going to do? I'm going to take the 3 over. So I have k equals 2 minus 3, which means k equals minus 1. And there we are. Minus 1 is our answer. So I hope you can see how quickly and efficiently I've now got the answer and the value of k. You guys have done amazing work. This now brings us to our last question. So let's keep this up and keep going. So now once again, we'll label our sides, which is x1, y1, x2 and y2. We'll then write out our difference. We're starting with our gradient, which is minus 2 equals 8 minus k over 4 minus 2. That then gives us minus 2 equals 8 minus k over 6. We'll take the 6 over and we'll know it's going to become multiplied by 6. And that will then give us minus 12 equals 8 minus k. And if we take that minus k over, we'll have minus 12 plus k, which equals 8. And then we'll take that minus 12 back over, so we have k equals 8 plus 12, and we know that is 20. And so our answer is 20. Marvelous work. And that there brings us to the end of our session. I hope we've given you a clear introduction to working out the gradient of a straight line graph and also calculating a gradient passing through a certain coordinates. Please don't forget that the gradient is a measurement of a slope. And in terms of the gradients of two lines being the same, and further to parallel and perpendicular lines, please watch out for our next video where we will be going through that specific topic. I hope you had a great insight into this specific topic, but don't forget to write your comments below and your feedback so we can take these on board and focus on certain areas that can help you improve your understanding on the topic. But with that in mind, keep up the great work and I'll see you in the next video.